Okay, we're going to talk about converting equations either from rectangular form to polar form and from polar form to rectangular form. So I want to remind you that the relationships we have are that x squared plus y squared equals r squared, which is the same as saying r is equal to the square root of x squared plus y squared. And then we also have that cosine of theta equals x over r, which we can write as x equals r cosine of theta, and sine of theta equals y over r, which we can write as y equals r sine of theta. So we're going to use these to convert the following. So when we start with things in rectangular form, x and y's, and we're converting them to polar forms, r's and thetas, we want to make sure in our final answer there aren't any x and y's, there are only r's and thetas. So here we have 3x plus 2y equals 8. And this would graph as a straight line. So we want to see what would that look like in polar form. So here where we have an x, we're going to plug in r cosine of theta, since that's what x is equal to, plus 2. Y is equal to r sine of theta equals 8. Now what we can do here is pull out an r, since both terms have an r, and we can actually solve for r. So if we pull out an r, we'll have r, this term will have 3 cosine of theta plus 2 sine of theta equals 8. And if we want to solve for r, we would divide both sides by 3 cosine of theta plus 2 sine of theta. So here we see that a straight line would look like the form 8, or this particular one, but they would all be in this kind of same form, cosine theta plus 2 sine theta. And we notice that, you know, a straight line in rectangular form isn't too bad. We'd solve for y and we'd have y equals mx plus b. It's easy to graph. This looks pretty complicated when we're graphing a line in polar form. So that's one of the benefits of rectangular form. It's much easier for graphing straight lines. Okay, but let's look at circles. So here we have x squared plus y squared equals 16. And sorry, I scrolled up here. We're going to use this fact that x squared plus y squared equals r squared. So we can say r squared equals 16. And now when we want to solve for r, we would take the square root of both sides, and we would just say r equals 4. So a circle in polar coordinates actually just looks like a constant, and that should kind of make sense, because if we have, you know, in polar form we have our graph paper kind of looks like this. And so if we just wanted to graph r equals 4, we'd be plotting all points where the radius was 4. Okay, so that would give us a circle. So circles are complicated to graph in x and y's, and in fact, if you were going to use your calculator, you'd have to put in 2 equations. But in polar form, they're very simple. So that's the benefit of polar form. It's much easier to graph circular things or round things. Okay, now we want to go the other way. We want to convert between polar equations and to rectangular form. So remember, we have r equals the square root of x squared plus y squared. We have x equals r cosine of theta, and y equals r sine of theta. So here where we just have r equals 7, which would be a circle like we just talked about with radius 7, for r we would plug in the square root of x squared plus y squared. And to make this look a little nicer, we'd square both sides just to get rid of that square root. And we would write this as x squared plus y squared equals 49, which would be the standard form, the rectangular form of a circle centered at the origin with radius 7. Let's look at one more. Here we have r equals sine of 3 theta. Okay, so the first thing we can do for r, we can put in the square root of x squared plus y squared And for sine of theta, we can put in, we know sine of theta, up here if we have y equals r sine of theta, we would have y over r equals sine of theta. So this would be y over r. And now r here, we can also put in the square root of x squared plus y squared. Now, if we want to clear this out of the denominator to make it a little simpler, or you could think of cross multiplying here. So we would have the square root of x squared plus y squared times the square root of x squared plus y squared, which the square roots would cancel out. So we'd get x squared plus y squared equals 3y. Okay, and that would kind of be as simple as we can get it. So that would be our equation in standard form.